Brief description. Description of MSDAC Siemens make AZS 350U. It is a 2 out of 2 microcontroller based system. It can be used for wheel detection at a maximum workable speed of 400 km per hour. When a wheel enters the sensing range of the double wheel detector, that is DEK 43, it causes an increase in the magnetic coupling between transmitter and receiver. This will be sensed by the trackside circuit board, that is TCB, and will generate digital pulses. These pulses are transmitted via a connecting cable to the evaluation computer for processing purpose. The evaluation computer does the following function. It evaluates the signals transmitted from the counting heads. It compares the number of axles counted into a track vacancy detection section, that is TVDS, with the number of axles counted out. It monitors the track vacancy detection sections and generates a track clear or occupied indication. Design features. It has the following salient features. Maximum 5 counting heads of EZP43 can be attached directly to the evaluator, or else maximum of 6 EZP43 can be connected remotely. It can detect maximum of 4 track vacancy detection section, that is TVDS. Its counting capacity is 32,767 axles per track section. Any number of AZS 350U can be linked in cascading manner. Bidirectional transmission of up to 24 items of user-defined operator-specific information can be received via modem. System architecture. The main parts of the system in MSDAC Siemens make are given below. Outdoor equipments. It consists of EZP43, that is counting head. Indoor equipments. It consists of evaluation computer, SIEMENS reset box. Outdoor equipments. EZP43, that is counting head. It consists of DEK 43 double wheel detectors, TCB trackside connection box, DEK 43 double wheel detector. The DEK 43 double wheel detector consists of 2 pairs of transmitters and receivers. The transmitters are kept in a housing located on the outer side of the rail, and the receivers are kept in a housing located on the inner side of the rail. These are insulated from the rails using reducing plates. The reducing plate is shaped to match the rail profile. 2 different frequencies, that is 3.5 kHz and 6.37 kHz, are used for channel working. Installation of outdoor equipments. The EZP43 wheel detection equipment, that is counting head, is installed at the limits of a track section. It comprises DEK 43 double wheel detector with connecting cables to the trackside connection box, that is approximately 5 meters long, optionally 10 meters. Trackside connection box. Rail mounting holes are to be drilled in the correct position as shown in the figure to ensure reliable working of the system. A is equal to height of the rail contact mounting holes from the base of the rail. B is equal to diameter of the hole. C is equal to inter-separation distance between the holes. A is equal to x plus or minus 1.5 millimeters, where B is equal to 13 millimeters. C is equal to 135 millimeters. X is equal to 85 millimeters for 60 kilogram rail. X is equal to 69 millimeters for 52 kilogram rail. X is equal to 56 mm for 90-pound rail. Diagram of double wheel detector components. Inner side of the rail. Outer side of the rail. Transmitter. M12 hexagonal nut. Spring washer. Square washer. Mushroom head bolt. Receiver. Producing plate. Tools required for installation, testing, commissioning and maintenance. Hole drilling machine. 13 mm drill bit. Spanners 19 and 13. Torque wrench with 19 inches socket. Screwdriver 3 by 32 inches. Multimeter for measurement of values. Extension card for measurement. Power supply for outdoor equipments. WDE supply voltage at counting head is 30 to 72 volt DC. As an option, the counting heads can be supplied with power directly from an on-site voltage source via an additional bandpass filter board for external supply in the EZP43 wheel detection equipment. Option for external supply at counting head minus 42 to plus 50 volts DC. External power supply for EZP43, which is optional. The wheel detection equipment can also be supplied externally with DC voltage or AC voltage. External supply is required if evaluation computer and wheel detection equipment are a great distance apart. In this case, the wheel detection equipment cannot be supplied via the core pair which carries the WDE signals. Power must be supplied via a second core pair or a different cable. It must be uninterruptible. Connecting cables. 24 by 0.2 shielded cables are used to connect the double wheel detector and the trackside connection box. They are approximately 5 meters long. Alternatively, 10 meters long cable is also present. Permissible distances. Permissible distance between double wheel detector of same design. When both wheel detectors are installed on the same rail, the distance between them should be more than 5 meters. When wheel detectors are installed on the opposite rails, the horizontal distance between the wheel detectors should be more than 1 meter. Permissible distances between double wheel detectors in point zone. The distance between any two detectors should be more than 1 meter. Permissible distances between double wheel detectors and tuning unit of AFTC. The double wheel detector should be installed more than 1 meter away from the boundary of tune zone of tuning unit. The distance between two wheel detectors on either side of the tuning unit shall not be less than 5 meters. Permissible distances between double wheel detectors and track magnet of AWS. The double wheel detectors should be installed more than 0.7 meter away from the track magnet of AWS. Trackside circuit board, that is TCB, of EZP43. Two variants of the trackside connection box are available. E-type, that is cast aluminum housing. V-type, that is plastic housing. Both variants of the trackside connection box are of IP, that is Ingress Protection 67 rating for protection from air and dust. It has a removable, lockable cover. A mounting rack is installed in the trackside connection box. The electronic components required for controlling the double wheel detector and pre-processing the detector information are accommodated on plug-in circuit boards. Its components are: 1 is wiring backplane including over voltage protection and tuning components, that is core to core. 2 is connection for WDE service equipment. 3 is bandpass filter board and power supply. 4 is generator board with adjusting controls for signal frequencies. 5 is supplementary board for WDE double usage. 6 is adjusting control for signal frequency 1, that is 3.5 kHz, and frequency 2, that is 6.37 kHz. S1 is rotary switch for transmitter frequency, that is 43 kHz. Termination details of trackside connection box. Working of EZP43. When a wheel passes over the double wheel detector, the magnetic coupling between the transmitter and receiver increases. Consequently, the induced voltage in the receiving coil increases. The induced voltages in the two receivers are transmitted via the connecting cable to the two separate receiver amplifiers in the TCB. After filtering, the amplitude of the receiver signals is raised to the appropriate level in the downstream amplifier, and then the amplified signals are rectified. Two voltage frequency converters generate square wave voltages from these amplified signals, whose frequency depends on the amplitude of the rectified receiver voltages. The downstream bandpass filters only let the fundamental wave of this square wave voltage pass. If a wheel enters the sensing range of the double wheel detector, the receiver voltage raises above the quiescent voltage, that is voltage, when no wheels are passing. Then the voltage frequency converter reacts by increasing the frequency beyond the upper band limit of the bandpass filter, and the signal gets attenuated. This corresponds to the occupied state of the double wheel detector. Subsequently, the transformer combines the signals of both channels and feeds them into the signaling cable. In addition, the transformer separates the supply voltage received from the interlocking from the signals to the transmitted to the evaluation computer. Double usage of counting heads. When using the double usage function, the WDE signals of one counting head are jointly used by two adjacent evaluation computers. This function results in economy of counting heads. There are three types of double usages: analog double usage, digital double usage via Series 2 board, analog double usage. The connection of a counting head, that is outdoor equipment, to two evaluation computers, that is indoor equipment, is called analog double usage. For this purpose, a supplementary board in the trackside connection box of the counting head needs to be provided for the analog WDE signals to be transmitted to both evaluation computers. An additional cable also needs to be provided between the counting head and the second evaluation computer. Digital double usage. WDE signals are transmitted between two interconnected evaluation computers. No additional cabling between indoor and outdoor equipment is required for this multiple usage of WDE signals. Digital double usage is implemented by connecting a sending evaluation computer to a receiving evaluation computer. The evaluation computer, to which the counting heads are directly connected and which transmits the WDE signals to the receiving evaluation computer, is called the sending evaluation computer. The receiving evaluation computer evaluates the digital WDE signals transmitted by the sending evaluation computer. The counting heads are connected to the sending evaluation computer via internal connector 20. 5 counting heads can be directly connected to the sending evaluation computer. The sending evaluation computer and the receiving evaluation computer are interconnected using internal connector 22. When using the double usage function, the number of counting heads that can be directly connected to the receiving evaluation computer is lower. If, for example, one counting head is jointly used, only a maximum of 4 counting heads can be directly connected to the receiving evaluation computer. This, however, also reduces the number of Vespa boards required. The WDE signals are transmitted at TTL level using a 2-core shielded cable that is lesser than or equal to 12 meters. Double usage via Series 2 board. WDE signals can also be jointly used by connecting 2 evaluation computers via a Series 2 board, that is 24-volt interfaces. In addition to the WDE data of up to 5 directly connected counting heads, this mode of connection permits the WDE information of up to 6 counting heads of an adjacent evaluation computer to be also used. Indoor equipments. The indoor equipment consists of the evaluation computer, which is installed near station. Evaluation computer. Evaluation computer is the heart of the AZS 350U axle counter system. It consists of SIEMENS fail-safe microcomputer system from Messrs Siemens. It does the following functions. It evaluates the signals transmitted from the counting heads. It compares the number of axles counted into a track vacancy detection section with the number of axles counted out. It monitors the track vacancy detection sections and generates a track clear or occupied indication. Overview of boards. The brief summary of AZS 350U components is tabulated below. Mounting frame, that is MF1 number. Processing and monitoring board, that is VAU 2 numbers. Control and diagnostic board, that is STEU 2 numbers. Block input and output board, that is BLEA12 2 or 4 numbers. Serial computer interface universal board, that is Series 2 0 or 1 number. Amplifier, trigger and bandpass filter board, that is Vespa 0 or 5 numbers. Digital double usage board, that is Digido 0 or 1 number. Power supply board, that is SVK2 150 1 number. The plug-in circuit boards are accommodated in a single tire mounting frame with wiring backplane. Dummy boards are inserted in free slots for optional boards. Series 2, that is Serial Computer Interface Universal Board. For controlling data transmission between evaluation computers, AZS 350U has a Series 2 board. The Series 2 board provides 2 bidirectional serial interfaces, that is SST1 and SST2, each equipped with a V24 output. Interface SST1 has 2 control signals, that is RTS1 and CTS1. For the transmission of fail-safe data, FACET, that is fail-safe single-channel transmission of status information, is used. On the front panel, there is a 48-pin connector providing the connection for all interface signals. An optional front connector with 2 9-pole sub-deep sockets is used for modem connection. A service PC can be directly connected via a 2-pole diagnostic socket. BLEA12 boards. The BLEA12 board is the input or output interface of AZS 350U. It has 12 floating relay outputs and 12 floating opto-coupler inputs. Inputs and outputs are made via a 48-pin connector on the front panel of the board. The BLEA12 board is a single-channel board. For the dual-channel AZS 350U, 2 BLEA12 boards are required. A maximum of 4 track clear or occupied indications with the associated reset restriction, that is RR, and reset acknowledgement, that is RAR output. The remaining inputs and outputs can be used for user-defined, operator-specific information, for example, block information. The 4 buttons, that is T1 to T4, on the front connector of the first pair of BLEA12 boards permits connection of the AZGRH button. The BLEA12 board executes the following functions. Output of track clear or occupied indication, that is CL, and minus CL of up to 4 TVDS. Output of reset restriction, that is RR, of evaluation computer for each TVDS. Output of reset acknowledgement, that is RA, on successful axle count reset for each TVDS. Input of immediate or preparatory axle count reset, that is by activating the AZGRT or VAZGRT button for each TVDS of the evaluation computer. Input of cancellation of reset restriction, that is RR, by activating the AZGRH button for each TVDS via optional front connector. Configuring by means of 96 dip switches. Block inputs or outputs for freely configurable operator-specific information. STEU control and diagnostic board. The STEU board buffers the signal transmitted by the counting heads. There is one STEU board per channel. The LEDs on this board display the following. Normal display. Display of the operating states of the 4-track vacancy detection sections, that is during operation, operating state display. Statistics display, that is diagnostics. Display of operating states for a certain counting head or track vacancy detection section, that is switch over or selection via AZGRH button. Display after emergency shutdown. Display of operating states in case of emergency shutdown. The 2 STEU boards display, that is normal display, the operating states for track vacancy detection sections 1 to 4. STEU1 channel 1 displays TVDS1 and TVDS3. STEU2 channel 2 displays the states of TVDS2 and TVDS4. For example, the following statistical and diagnostic data can be displayed. WDE related data. Total number of axles since the last system startup and number of axles detected by the counting head. Total number of supply voltage failures since the last system startup. TVDS related information. Operating state for the TVDS. Total number of occupancies since the last system startup. Block information. Distribution of block information, that is contents defined by the railway operator. System information, for example, software version, software variant. For details, see topic STEU board LED indications. VAU and CPU board. The processing and monitoring board, that is VAU, and a CPU board constitute the fail-safe microcomputer system, that is SIEMENS C computer core. The VAU board provides monitoring and comparator functions for synchronous dual-channel microcomputer operation. It has 2 VAU boards with 2 MHz 8085 microprocessors, which are the central circuit boards of the microcomputer system. They have an 8 KB RAM and a 32 KB EPROM. Due to the dual-channel layout of the evaluation computer, there is one VAU board per channel. The VAU board is a SIEMENS C CPU board in which two independent MES80 microcomputers are connected without additional circuits to form a clock-synchronized dual-channel microcomputer system providing SIEMENS core functions. Each VAU board monitors and compares the synchronous and identical operation of both microcomputers and, in case of a fault, transmits a switch-off control signal, that is SCS, in order to disconnect the connected signaling and safety peripherals. For a synchronous start of the evaluation computer, after a failure, both VAU boards have a system reset button. Pressing both red buttons simultaneously for approximately 1 second will restart the evaluation computer. The SIEMENS online test program, that is SOPP, is started after initialization. The complete interruptible program run takes approximately 4 minutes. The SOPP program is a low-priority program executed in the background and is always quiet after an interrupt request. If both LEDs VGL on the VAU boards light up, the evaluation computer is operational. A lit LED SPW indicates that the operating voltage is above or below the permissible value of 5 volt DC. Then the system has to be restarted. A lit LED PAB indicates a program-controlled emergency shutdown. That is, if the comparator has detected asynchronism in the operating system, or if during the continuous test cycles a safety-related fault has been detected. This initiates a hardware or software controlled shutdown, and the evaluation computer switches to the occupied state. The system then has to be restarted. The causes of faults can be identified via the LEDs, that is LED 0 flashing permanently on the STEU board. For details, refer to troubleshooting using STEU board LED indications. During startup, the LED ANL lights up for approximately 3 seconds. Vespa board signal generation board. The functions of the Vespa amplifier, trigger and bandpass filter board are as follows. Connection of EZP43E by VVL detection equipment. Supply of power, that is from SVK2150 to counting heads. It generates digital high and low signals, that is WDE signals, in absence and presence of wheel on the wheel detector respectively. Each directly connected counting head, that is counting head 1 to counting head 5, requires one Vespa board, that is numbering of counting heads. 1 to 5, it provides electrical isolation between indoor and outdoor equipments, that is counting head. The Vespa board splits the signal frequencies F1, that is 3.5 kHz, and F2, that is 6.37 kHz, into two independent channel frequencies. It filters, amplifies, rectifies, and evaluates the data received from the counting head. On the front panel, there are measuring sockets for fault diagnostics as well as LEDs for displaying the state of passage and a potentiometer for adapting to different cable lengths and setting the transmission level. When the yellow LEDs on the front panel light up, they indicate that a train is passing the track installed wheel detector. In normal operation, these LEDs light up for a brief period depending on the train speed. The counting heads are protected via fuse SI1, which is mounted directly on the front panel, and another fuse on the printed circuit board. Parts of Vespa board. 0.2 amperes counting head fuse, which is used for both system 1 and 2 of double wheel detector. Yellow LED, which lights up when system 1 of double wheel detector is passed by an axle or V1 is less than 1.3 volt DC. Potentiometer used for adjustment of V1. Measuring socket for frequency F1. Measuring socket for voltage V1. 0 volt measuring socket for both systems. Measuring socket for frequency F2. Measuring socket for voltage V2. Yellow LED, which lights up when system 2 of double wheel detector is passed by an axle or V2 is less than 1.3 volt DC. Potentiometer used for adjustment of V2. Digido board. The digital double usage board, that is Digido, is used if WDE information to be jointly used by two evaluation computers. The optional Digido board is used to connect AZS350U to other AZS350 systems for digital double usage of counting heads. For details, check double usage of counting heads. SVK2150 power supply board. The SVK2150 power supply board provides 5 volt for the evaluation computer and 70 volt for external operation of 5 counting heads. It electrically isolates indoor and outdoor equipment. The SVK2150 board is ready for operation when voltage is applied to the switching input. This is indicated by the yellow LED VIN. When the switch on the front panel is set to I, the yellow LEDs 5 volt and 70 volt, 12 volt is not used on the front panel indicate the presence of the voltages. And undervoltage causes the output voltages to be disconnected. In the case of overvoltage, the control circuit fuse, that is 0.2 amperes, fast blows. The unit can then only go back into operation after this fuse has been replaced. If there is no voltage at all, the input fuse on the printed circuit board, that is 8 amperes fuse, slow acting, has to be checked. For details, refer to topic 11, that is reference material. SIEMENS principle. The SIEMENS microcomputers process and evaluate the axle counting data and forward the results to the higher level interlocking circuits via the BLEA12, that is block input and output board. SIEMENS. The fail-safe microcomputer system from Siemens is given below. It has 2 identically programmed computers. Data is given to both the computers, which process the data independently. After processing, the output is given only when both the comparators produce the same results. A cutoff unit is connected downstream of the comparators for this purpose and de-energizes the output circuits if the output data does not agree. Summary of working. Each counting head is connected to one Vespa board. It generates the signal frequencies F1, that is 3.5 kHz, and F2, that is 6.37 kHz for channel 1 and 2 of a counting head. Moreover, the WDE signals coming from the counting head is received by the Vespa board. These WDE signals are then given to STEU channel 1 and 2 boards for evaluation. After evaluation, this information is given to VAU boards for processing and monitoring of data using SIEMENS microcomputers. The final output is given to the interlocking using BLEA12 boards. All inputs and outputs to and from the interlocking are done via BLEA12 boards. For transmission of WDE signals between two AZS350U units, Series 2 board is used. For WDE signals to be jointly used between two evaluation computers, Digido board is used. Technical data of evaluator. Counting capacity is 32,767 axles per track vacancy detection section. Maximum number of connectable counting heads per computer is 5 directly and 6 using remote control. Maximum number of track sections is 4. Section length, that is without data transmission between evaluation computers, is lesser than or equal to 42 kilometers. Section length, that is with data transmission between evaluation computers, is unlimited. Typical control distance is 6.5 kilometers. Maximum control distance is lesser than or equal to 21 kilometers. Output information, axle count reset, that is A is at GRT and VA is at GRT. Maximum 4-track clear indications, that is CL. Maximum 24 operator specific information units, for example, block information. Reset restriction, that is RR. And reset acknowledgement, that is RA. For wheels, material used is steel or cast iron. Diameter is greater than or equal to 300 millimeters. Width is greater than or equal to 115 millimeters. Wheelbase is greater than or equal to 700 millimeters. For track, sleepers used may be wooden or concrete or steel. Ballast resistance is 0 to infinity. Supply voltage is uninterruptible, 24 volt DC to 60 volt DC with tolerance of plus 20% and minus 10%. Each evaluation computer of power consumption is approximately 10 watts. Ambient temperature range of indoor equipment is minus 25 degrees Celsius to plus 70 degrees Celsius. System component of EZP43E or V counting head. Operating frequency is 43 kHz. Dimensions of trackside connection box, that is without pipe support and cable gland. For EZP43E, length is 360 mm, breadth is 360 mm and height is 210 mm. For EZP43, V length is 241 mm, breadth is 241 mm and height is 174 mm. Ambient temperature range of outdoor equipment is minus 40 degrees Celsius to plus 80 degrees Celsius. Power consumption is approximately 2.5 watts, that is without cable losses. Degree of ingress protection for trackside connection box, it is IP67. For double wheel detector, it is IP68. Adjusting values in idle state. For signal frequency F1, when detector not passed is 3.5 kHz. For signal frequency F2, when detector not passed is 6.37 kHz. These frequencies have been modified as per Indian Railways application. Installation of indoor equipments. A is at S350U axle counting cabinets. The cabinet accommodates the required number of evaluation computers, mounting frames, that is ECMF. Optional components such as ventilator, sub-assemblies, compartment bases and terminal modules are installed depending upon the cabinet type. Its cabinet has the following variants: S25552J605U1, that is U1 cabinet; S25552J605U2, that is U2 cabinet. It has mounting frame with plug-in circuit boards. It contains optional accessories such as compartment bases, pre-assembled internal connectors, pre-assembled connecting cables, axle counting cabinet S25552J605U1. This cabinet can accommodate a maximum of 6 evaluation computers mounting frames. Connection of counting heads. Within the cabinet, connecting cables lead from the backplane connectors of the evaluation computer mounting frame to the counting head terminals on the mounting plate. The cable connection to the intermediate distribution rack is made during installation on site. Connection of BLEA12 boards. Within the cabinet, connecting cables lead from the front connectors of the BLEA12 boards to terminal blocks, that is MOKAU. On the MOKAU modules, there are fuse holders for the outputs of the BLEA12 board. The cable connection from the terminal blocks to the intermediate distribution rack is made during installation on site. Axle counting cabinet S25552J605U2. This cabinet can accommodate a maximum of 9 evaluation computers mounting frames. 2 variants for connecting counting heads. The first variant permits connection via cables with backplane connectors directly to the intermediate distribution rack. For the second variant, the counting head connections are run via an optional terminal strip in the lower part of the cabinet using backplane connectors already during cabinet assembly. Connection of BLEA12 boards. Ready-made connecting cables with front connectors in the required cable lengths permit the BLEA12 boards to be directly and cost-effectively connected to the intermediate distribution rack, that is, different cable variants for the first and the second pair of BLEA12 boards. Power supply for indoor equipments. Input supply voltage to evaluation computer is 24 volt DC to 60 volt DC with tolerance plus 20% and minus 10%. The SVK2150 power supply board generates the following operating voltages required by AZS350U. 5 volt DC for internal operation. 70 volt DC for external operation of maximum 5 counting heads. Data flow between components. AZS350U transmits the track vacancy detection section data to the interlocking circuits via a parallel interface. Information is transmitted via the BLEA12 board, that is block input and output board. The process uses floating relay contacts and opto-couplers for information input and output. In addition to the dual-channel track clear or occupied indications, that is CL and minus CL, a single-channel reset restriction, that is RR, and reset acknowledgement, that is RA, are issued for each track vacancy detection section. The process data, that is passage of wheel, is collected by the EZP43 wheel detection equipment, evaluated and transmitted to the Vespa board at 2 signal frequencies, that is amplitude and frequency F1 and F2. In the interlocking, a dual-channel reset is issued via the AZGRT or VAZGRT reset procedure. There is an optional auxiliary axle count reset button, that is AZGRH, connected via two channels, which on dual channel activation cancels the reset restriction. By means of single channel activation of the AZGRH button, various statistical and diagnostic functions can be called up. User-defined binary coded data can be exchanged between systems. This data, for example, block information, is transmitted from one evaluation computer, that is EC, to another in transparent form. That is, there is no evaluation by the respective axle counting system. Information input and output is performed via the BLEA12 board. The facet data transmission procedure, that is fail-safe signal channel transmission of status information, provides the connection between the AZS350U systems. The transmission software enables the exchange of safety-related status information between the communication partners. Information is exchanged regularly and in both directions. The facet data transmission method connects the AZS350U systems via a modem link, that is any length restricted only by transmission medium. Over a shorter distance, two AZS350U systems may also be connected via a cable that is less than or equal to 15 meters without modem. The evaluation computer is connected via the Series 2 board. Each AZS350U evaluation computer is equipped with a Series 2, that is Serial Computer Interface Universal Board, with two V24 interfaces for remote data transmission between evaluation computers. When the W-usage function is used, the WD data of a counting head can be processed by more than one evaluation computer. There are two types of W-usage: analog W-usage and digital W-usage. A service PC can be connected to the indoor equipment. Data is transmitted via the V24 interface of the Series 2 board. The connection is established via modem, or as an option via a null modem cable that is lesser than or equal to 15 meters. Possible control distances of AZS350U: 6.5 kilometers, recommended value with direct power supply depending on interference voltage. 21 kilometers, with cable divided into several electrically isolated sections and with external power supply. Restriction by following parameters: cable capacitance lesser than or equal to 325 nanofarad, that is approximately 50 nanofarad per kilometer, with electrically continuous telecommunications lines. DC resistance of power supply cable greater than or equal to 30 volt DC at counting head, greater than or equal to 22 volt AC at counting head, that is with external power supply. Interference voltage lesser than or equal to 1.5 kilovolt RMS, that is transient, and lesser than or equal to 250 volt RMS, that is continuous interference. Attenuation of signal frequencies, different depending on cable type. SIEMENS reset box. Two methods are used for resetting the system: conditional hard reset, preparatory reset, conditional hard reset. For this operation, axle count reset button, that is AZGRT, is to be pressed along with line verification key from site. Then the system will be immediately resetted provided that no reset restriction, that is RR, is active. A reset restriction is active if the last axle registered by the axle counting system has been counted in. The reset restriction can be cancelled by a relief operator action using the auxiliary axle count reset button, that is AZGRH. Subsequently, the track can be given a clear indication by pressing the AZGRT button. Preparatory Reset. With preparatory reset, after pressing the axle count reset button, that is AZGRT, it only causes the axle count of the track vacancy detection section to be reset to 0. A section clear indication will appear only after the track vacancy detection section has been subsequently passed by a train. The passage of the train must comply with the station working rules for the preparatory reset. After an axle count reset operation, the train must pass at least 2 different counting heads in order to establish the clear status for the respective section. After an axle count reset operation, the train must pass all counting heads at the beginning and end of the TVDS section in order to establish the clear status for the respective section. This may involve several individual train passages. After an axle count reset operation, the train must pass all counting heads passed during the last train passage in order to establish the clear status for the respective section. Cables between indoor and outdoor equipments. Between DEK 43 and TCB, 24 by 0.2 mm shielded cables are used to connect the double wheel detector and the trackside connection box. They are approximately 5 meters long or alternatively 10 meters. Between EZP-43 and Central Evaluation Unit. The EZP-43 wheel detection equipment is connected to the evaluation computer via 2 wires of a 0.9 mm star quad cable. This cable is used to transmit the WDE signals to the evaluation computer and to supply the counting head with power, that is, if it is not supplied from an external voltage source. Earthing. Earth resistance of the EZP-43 shall not be more than 1 ohms. For details, refer to topic 11, that is reference material. Wheel detection equipment. Wheel detection equipment shall be inspected on every 12 months for high traffic density lines, every 18 months for the other lines. Scope of inspection. Visual inspection of all parts for damage and secure fittings. Diagnostics. Outdoor equipment. Outdoor equipment related adjustment and control measurements are performed with the help of WDE test equipment. EZP-43E or V provides a mounting location for this purpose. The test equipment is connected via a plug-in connection for diagnostic purposes. The following test equipment is used. Test adapter board. The test adapter board can be used during commissioning and maintenance for testing and adjusting work on the wheel detection equipment. The necessary voltage and frequency measurements can be performed using a commercially available multimeter. The front panel of the board has measuring sockets arranged in pairs to which the multimeter can be connected. The test adapter board is inserted in the corresponding mounting location in the trackside connection box of the EZP-43E or V wheel detection equipment. Indoor equipment. The front panels of the boards are having LEDs to indicate the status or cause of possible faults of the axle counting system. In addition, the LEDs provide statistical information, example, the number of track section occupancies or the number of axles having passed a counting head. Moreover, it is having a service PC which can be used for getting information of up to 9 evaluation computers. For this purpose, the service PC is connected to the serial interface, that is Series 2 board of the evaluation computer. 8 evaluation computers can be serially connected via a converter. The 9th evaluation computer is connected directly to the free serial interface of the service PC. The following information of the connected evaluation computers is displayed via the diagnostic software. All 9 evaluation computers clear an occupied state corresponding to each TVDS. TVDS, counting head, axle count, error count of each evaluation computer at a time. Remote diagnostics via modem is also possible with the service PC. The relevant information is transferred to a maintenance center for analysis by maintenance staff. The mode of visualization is the same as on the service PC on site. The information given by some of the boards through LED display is given below. For VAU board, yellow LED, that is VGL, shows the comparator. First red LED, that is SPW, shows the voltage controller. Second red LED, that is PAB, shows the program control shutdown. Third red LED, that is ANL, shows the startup. Red button is used for system reset. STEU board. STEU1, that is for channel 1, displays track vacancy detection system 1 and 3 information. STEU2, that is channel 2, displays track vacancy detection system 2 and 4 information. For track vacancy detection system 1, following LED indications on STEU1 board are used. LED 0. Its steady indication shows that the system has been reset. Now, GRT is required to be pressed. LED 0 flashing indication shows that the program control emergency shutdown of evaluation computer has occurred. LED 1. Its steady indication shows that out counts are more than in counts, that is negative axis. Our counting capacity increased or undefined counting pulse has occurred. LED 2. Its steady indication shows that count monitoring double wheel detector traversed on one channel only, that is shunting movement. LED 3 and 4. Its steady indication shows that telegram transmission between evaluation computers is faulty or the second evaluation computer is shut down or reset restriction, that is RR, is effective. LED 5. Its steady indication shows that section is occupied. LED 6 to 11 related to track vacancy detection system 3 are same as LED 0 to 5. LED 0 to 5 of STEU2, which are related to track vacancy detection system 2, are same as LED 0 to 5 of STEU1. LED 6 to 11 related to track vacancy detection system 4 are same as LED 6 to 11 of STEU1 board. For SVK 2150 board or power supply board, first yellow LED, that is 12 volt, is not used in AZS350U. Second, yellow LED, that is 5 volt, shows that computer voltage is present. Third, yellow LED, that is 70 volt, shows that WDE supply voltage is present. Fourth, yellow LED, that is V in, shows that input voltage is present. 0.2 amperes fast blow fuse is provided on the power supply board. On and off switch is provided for switching on and off of power supply board. For details, click here. Troubleshooting. EZP43 wheel detection equipment. Fault is the WDE supply voltage U60 is below 30 volt DC. Following table may be referred for troubleshooting. WDE supply voltage U24. Fault is the internal WDE voltage U24 is lower than 21.3 volt DC or higher than 22.4 volt DC. Following table may be referred for troubleshooting. Signal frequencies F1 and F2. Fault is signal frequency F1 and F2 is out of the tolerance range. Following table may be referred for troubleshooting. Receiver voltage UE1 and UE2. Fault is receiver voltages are less than 60 millivolt. Following table may be referred for troubleshooting. Evaluation computer. Vespa board. Fault is yellow LED of the Vespa card is continuously lit, that is no wheel on the detection point. Following table may be referred for troubleshooting. Check that the voltage U60 at the counting head is more than 30 volt DC. If not, check the quad cable from the central evaluator to the counting head. Check that all the electrical parameters are within the specified range. If not, adjust only three frequency values: 43 kHz, 3.50 kHz and 6.37 kHz. Check that the bolts of the wheel detector are tight. Use only a torque wrench of 75 Newton meters to do this work. Check the above only if no fault is found at the central evaluator, and otherwise only once in 3 to 6 months. Adjust the frequency values only if they are outside the permissible range specified. Don'ts. Do not use any tools other than those provided specifically for tightening the bolts on the wheel detector. Do not tighten the bolts after frequency values have been adjusted within the specified range. These values can be changed after tightening the bolts. Applications. It can be used for station section, that is straight or point zone section. Its evaluator can detect a maximum of 5 counting heads, that is EZP43 connected directly, or else maximum of 6 EZP43 connected remotely. It can detect a maximum of 4-track vacancy detection section, that is TVDS. It can also be used for block section applications. Limitations. For smaller applications, that is 3 or 4 detection points, it becomes costly. Longer length of communication cable is required for connection of outdoor equipments with central evaluator. Miscellaneous. Glossary. AZS350U means multi-section digital axle counter of Siemens. DEK43 means double wheel detectors. WDE signal means wheel detection equipment signal. TCB means trackside connection box. EZP43 means wheel detection equipment, that is counting head. TVDS means track vacancy detection section. Vespa means WDE signal generation board. STEU means control and diagnostic board. VAU means processing and monitoring board. SIEMENS means microcomputer. BLEA12 means block input output board. Sirius 2 means serial computer interface universal board. AZGRT means axle counter reset button. AZGRH means auxiliary axle counter reset button. VAZGRT means Preparatory Reset button. CL means Track Clear or Occupied Indication. RA means Reset Acknowledgement. RR means Reset Restrictions. CH means Counting Head. Facet means Fail-Safe Single Channel Transmission of Status Information